Ben, thank you so much for inviting me here, for moderating today. And thanks for everyone joining the call. Really appreciate it. I know I wish I could be there in person. Ben was just commenting the fact that it was a year ago that I was actually in Munich in person, and really enjoyed my time there. Always love coming to Germany. But hey, let's get into some discussion. We got only 30 minutes, so we want to leave a little time for questions at the end. Let's just talk some technology this morning. And let's cover Azure SQL performance fundamentals. My name is Bob Ward. I'm an architect for the Azure team. It's funny that you may hear that. You're like, architect for the Azure team. I thought you were a SQL Server person. But it turns out, starting about last December, early January, I started spending some of my time also focused on Azure SQL. And I think you're going to enjoy today's session because I'm going to talk about Azure SQL performance, comparing performance capabilities and monitoring and some tasks you'll like to see to SQL Server. So if you know SQL Server, you're going to be able to understand what I'm talking about today and compare it to how you might do things in Azure SQL. Now, you're probably asking yourself, like, how do I get this deck you're going to do? And how do I see some of the demos? Here's the good news. If you go to this website, aka.ms, Azure SQL Workshop, the deck I'm showing is a subset of a module in this workshop for performance, and that includes in this module some hands-on activities. At the very end, I've got a resources slide where I'm going to show you another resource you can go to, where you can go through many of the things I'm talking about here for performance at a Microsoft Learn site, where you get a free Azure Sandbox to try it out. So without further ado, let's get going. So, I always put this slide up every time I'm talking about Azure SQL, and I'll just briefly talk about it because I get a lot of questions on what is Azure SQL. Azure SQL is a branding. It's a suite. It is the set of cloud services for SQL Server in Azure. That includes SQL Server and Azure Virtual Machine, an Azure Managed Instance, which is kind of like a SQL instance, right? Except we do platform as a service type capabilities for you in the background. And then finally, an Azure SQL database, a full platform as a service capability where you just provision a database. We handle everything under the covers, including the instance itself. It's going to light up some other technologies that you won't have on the two other options. This is the family of suite of Azure SQL today. And Anna Hoffman and I talk about this all the time about what this means, but I want to make sure you understand out of the gate. We're going to focus our time on the right-hand side for Azure SQL Managed Instance and Database from a performance perspective. And I say that because SQL Server and an Azure VM, inside the VM is a full SQL Server. So all the capabilities, the ways you monitor and use SQL, all exist the same there today. The difference being is how you're going to configure things outside the VM, things like storage and so forth. And there are plenty of content we have available for you to go figure those kind of things out. So I like to think in terms of capabilities. And if you think of capabilities for performance, one of the things you need to worry yourself if you worry about a SQL Server today is, what are my capacities? If I have to put a virtual machine together in VMware on a host server in my data center or set up a new server, how many CPUs do I get? How much memory do I need? How much database size do I have? And you should know that there are different options for you across managed instance and database. But here are some of the maximum capacities. If you didn't think that we didn't have maximum capacities, look at the fact that an Azure SQL database can be deployed in an option with 128 vCores and 4 terabytes of memory, or a hyperscale option can support 100 terabytes or more of a database size, or even a managed instance up to 80 vCores. So know that you have these kind of capacities, and this is something that, now that I've gotten involved with this team more, we spend all the time talking about how do we continue up the game here with these capacities for these different options. Now for indexes, all your indexes are supported. If you're worried about the fact that I can't do a column store index in Azure SQL, you can do it in almost every tier and almost every option we provide. If you don't know, can I rebuild or reorganize my indexes? There are my scripts that use that today. Does those work? They all work. In fact, online and resumable all work as well. And if you're using Hackathon in Remote TP, if you use something called our business critical tier, you get access to that feature. And just like in a SQL Server today, your memory capacity for that will be a portion of the overall memory limit that we give you for your deployment. And then partitions, sorry, a little bit too fast there. For partitions, we support partitions. The only thing about partitions that's a little bit different here is that we only support file group placement in managed instance, but we don't support file groups. We'll talk about it in a second. We don't support physical organization of file groups and files in Azure. You don't need to do that. But if you do want to still partition your tables, that functionality exists both for database and managed instance. And you may have heard me talk about SQL 19 performance enhancements. That does exist today. And in fact, many features like intelligent query processing started in the cloud first and made their way into SQL 19. And almost everything you have in SQL 19 from a performance enhancement perspective does exist in Azure, but not 100%. For example, TempDB metadata optimization, which I've spoken about extensively, that's not yet available today in Azure SQL, but pretty much a lot of the things that I've talked about before from a performance enhancement perspective, they all exist in Azure. Okay, if you've got to go configure something for SQL Server, you do have to do some configuration choices for performance, and TempDB could be one of those things. A lot of people pay attention to that, obviously, right? Especially if you have workloads that are dependent on TempDB. Well, know this, we always keep TempDB files on local SSD drives. You don't even have a choice. We just put them on SSD drives. So I/O performance is never an issue in Azure with TempDB. I've never seen it be in Azure. But you may be concerned about how many files you need. Well, you do not get to choose these files, either in MI or in database. But notice in Azure Database, we will scale the number of files as you pick something called vCores. As you say, hey, I want 8 vCores, we'll give you X number of files to match that or exceed that. And then these options you pick that you're used to using with trace flags before, those things are the defaults as you see in SQL 19 today. And I mentioned that TempDB metadata optimization, isn't supported yet. That's something we're certainly looking at. My perspective overall about TempDB is that I have found that pretty much we have configured things for you and your workload just works. You don't need to spend a lot of time worrying about TempDB configuration in Azure. That's been my experience with customers and my own testing of the options. So what about database configuration? You're going to see in a second here, you have alter database capabilities. Sorry, I'm not covering that in performance today. That's covered in a different module in our workshop. But you should know that alter database scope configuration, most of those options are available to you in Azure SQL. From a performance perspective, the one you should pay attention to the most is recovery models. We only support the full recovery model. That is it. We need to do that in order to meet our service level agreement for you for uptime for Azure. So minimal logging is not possible. You can do it in TempDB, but you can't do it in a user database. And then I mentioned a little bit before about file groups. We do support in managed instance the ability to add files and change sizes of files. And in fact, doing that could actually give you better performance in something called the general purpose tier. But we don't support physical placement of files. And you may be sitting in this call going, well, wait a minute, that's a problem for me from a performance perspective, but it shouldn't be, because we have certain promises about I/O performance depending on your choices. And so as long as we meet that, who cares about this? In fact, it could be a nice thing that you don't have to worry anymore about where these files go. Because remember, in a managed instance in a database, we're running the infrastructure for you. We're worrying about that. You don't have access to disk drives and so forth. We just figured that out for you. Max DOP, obviously a very popular term that people talk about all the time. All the options you're used to are supported for Azure SQL. Whether it's alter database, SP configures, query hints, all those things, those all work. Now, in some cases, you only get to do certain things in managed instance because it's an instance. And in fact, in managed instance, we do support a user-defined resource governor workload group or pool. And so therefore, you could set max DOP for a resource group pool in managed instance. For Azure Database, you don't have access to the entire instance. So anything that's instance level, like SP configure, for example, wouldn't be allowed. But alter database scope configuration and a query hint would be allowed. So these are some of the common questions that I've gotten or that I observed as I looked at SQL Server, how to configure for performance and compare that to Azure. Oops, a little bit quick on the trigger this morning. So monitoring is obviously one of the biggest things you have to do today with SQL Server. And you may be worried or wondering, do I get DMVs? Do I get extended events? You get all those things. We'll talk about a little bit more in a second about those. But know this, just like today in your environment, say on Windows, where you would use like Performance Monitor, we have something called Azure Monitor. So Azure SQL will snap into the Azure infrastructure, the ecosystem, to support metrics, alerts, and logs within the Azure Monitor system. I'll show you an example of that in a demonstration. And things like lightweight query profiling, which I talked about in SQL 19, that works, and that is on by default in Azure SQL. Query plan debugging using set statistics IO, set statistics time, all that stuff works. And most importantly, query store. is on by default in managed instance in Azure Database, and it's going to be used to light up some new functionality that you don't actually have today in SQL Server, like some visualizations in the Azure portal. So speaking of DMVs, which have been around, as you know, for a while, are a very important resource to a lot of people. In managed instance, you get every DMV you get in SQL Server. Server resource stats is a new DMV you get specifically to monitor resource usage for your managed instance. For Azure Database, most of the common DMVs available, in fact, I think everything that you typically want is going to be there, DM exec request, for example. And then some new DMVs are also available to look at resource usage, things like CPU, memory, IO, and so forth from a DMV perspective, and that's specific to Azure SQL. Now, I like to kind of geek out a little bit. So there are other DMVs you may want to look at. Notice here on the left-hand side, IO virtual file stats. Since you don't have access to things like perfmon, this is how you're going to look at things like IO latency for SQL Server. Even though you don't specify the file location, we will show you IO latencies so you can ensure that your workload is performing correctly using that DMV. And instance resource governor and user DB resource governance. These DMVs are special to Azure. It's a way for you to go in and see the configuration of your deployment to see what are your limits. What's my max IOPS? What's my max DOP? What's my max worker threads? All that kind of type stuff is special to Azure, and we light those up for your Azure SQL deployment. And then on the right-hand side, we've got some internal DMVs. The first one is undocumented. Pretty interesting to look at. The second two are very interesting, and we actually use these two bottom DMVs to help monitor customer workloads to help solve problems in the cloud. So those are DMVs. For extended events, you're asking yourself, like, I need tracing, so do I get that? Yes. Azure SQL Database, most of the common events and actions you use today for X event work, and your things like file, ring buffer, and counter targets all work as well. But here's one of the big differences. For file targets, remember, you don't have access to the underlying operating system, so you're going to put your Azure file targets in Azure blob storage, and we have documentation for how that works. And then you'll go read from those file targets with tools or with system functions. For Azure Managed Instance, think of it just like a SQL Server. All events, targets, and actions are supported. But again, those file targets are going to go to Azure blob storage. So if you think about DMVs and X events, they're all going to work for you just like it works in SQL Server today, with a few minor differences. Now, I have this interesting chart to show you how you look at a problem, and then we're going to go look to see what that problem looks like in a demonstration. And that is, when I look at performance problems, I look at it to see whether they're running or waiting. And I do that even for SQL Server. But the differences is sometimes I have to use different techniques for Azure to figure out the problem. So to check resource consumption, like is it CPU or not CPU, I need to use these DMVs for Azure, or I use Azure Monitor. I look at the portal, or you can use PowerShell or alerting to say what's going on with my deployment. Now, if I find that it's a CPU problem, or what I call a running problem, like high CPU, I might look at these techniques. Now, if you look at these techniques, Query Store and these other DMVs, it's the same as SQL Server. An SOS scheduler yield weight, which is kind of like an indication of lack of CPU resources, is the same in Azure SQL as it might be in SQL Server. But if it's not a running problem, it's probably a waiting problem. And it could be one of these wait types that you see here. You've seen before write log waits or latch IO waits, or whatever it may be. You've seen these things before, and you're going to use the same DMVs or Query Store to go debug these problems. Or it could be your favorite tool that uses this technology to tell you, is it running or is it waiting? So I think this is a very interesting way for you to break down performance problems. I find it very handy because most performance problems are vague in nature, and you can use the same technique with SQL Server, and again, you can use it with Azure SQL. Now, with Azure SQL, there are some specific scenarios that you wouldn't see in SQL Server. So for example, we, in order to meet SLAs, may throttle the amount of transaction logs you generate from your application, okay? And if we do that, you might see a wait type called like log rate governor. That means, hey, we're throttling the amount of log you're generating. So you may go look at your workload to see, do I need to bump up my vCore choice or my deployment option, or look at my app to see whether I may be incorrectly generating too much log. And you can see here, in the case of an elastic pool or a managed instance, the wait type may change slightly. Now, the other thing is worker threads and worker limits. For Azure SQL Database, since you don't have access to the entire instance, we actually have specific worker limits that we document, and you get an error message if you exceed that. So your app needs to be built to retry. Oh, I've exceeded this worker limit. I need to either retry or go figure out why am I exceeding my worker limit. For managed instance, you're going to see what you see in SQL Server today. You're going to see a thread pool weight, and max worker threads are used there to adjust that option if necessary. But again, remember, in the worker limit scenario, unless you've got a very low worker limit, it could be that you have a large blocking problem or an issue you need to go tackle, and it's not that you need to bump up your limit. Now, we have something called the business critical service tier, and behind the scenes, we deploy an always on availability group for you automatically that you don't realize, but you take advantage of that replica technology. So you might start seeing these wait types like header sync commit, and you didn't realize why you would see that because you didn't deploy an availability group. But since we do that for you, these show up. So I've had customers ping me and say, hey, I didn't do an availability group. Why do I have header sync commit wait type showing up? And we're like, hey, that's normal because we're behind the scenes are deploying that for you in order to meet the needs of what's called a business critical tier. And then Hyperscale, one of the unique options we have for Azure SQL Database, has a unique architecture where you still could get log rate governor weights, but because of our caching architecture that we deploy, it could be one of something called a page server that we use is behind in getting log changes. And if that occurs, you might see something called an RBIO wait. There's several of those documented. And if that shows up, is something going on with the caching architecture? It could be a log generation problem, or it could be a problem with the service that you need to work with us on. In addition, I mentioned this concept called a page server. Think of that like as an intermediate caching of pages that we have. And so we've added diagnostics in our DMVs, views, and extended events to show you what does the page server reads look like at that level. And sometimes that could be helpful to go diagnose a problem. So you can see here, looking at performance problems is just like SQL Server, but it can be slightly different in some cases for Azure, something unique to Azure you wouldn't see in a SQL Server. Now, if you run into performance problems and you need to make performance faster, there's a couple of considerations for you. Number one is scaling CPU capacity. How would you do that today in your environment? Well, you might have a virtual machine, and so you just go ask your admins, can I have some more virtual cores? And they turn around and say, sorry, we're out of virtual cores on this host. We're going to have to move your VM. And you're like, great, I got to move my VM. That might require even a database migration. In Azure, that's not the case. You can scale CPU capacities up or down. Sometimes it can be very, very fast. There's no migration required. We do all of that for you. You can do that through the portal, through T-SQL, PowerShell, or even REST APIs. Hyperscale can scale in constant time. So that even if you have very, very large databases, we can scale up and down hyperscales very quickly. And then what's not listed on here is a concept called serverless, where we can do auto scaling for your workload. And what about I/O performance? I mentioned that we have documented things like what are the IOPS you get for your deployment, and that may show up in terms of longer I/O waits if you're restricted on that. But we also have promises about I/O latency. So for example, if you need really low I/O latencies, you should consider using something like business critical service tiers, where your database is deployed on local SSD drives versus like Azure storage. And then just like in a SQL Server scenario, if you got log I/O latency, sometimes you just need to do multi-statement transactions. I've got a lab at our workshop you can go take a look at to see what that kind of problem is, what the symptoms look like for that problem, for your application. And then we talked about memory and worker limits. I talked about worker limits, but I didn't talk about memory. If you need more memory for buffer pool, this is a matter of you choosing a different option, like more vCores or going to business critical or going to hyperscale or something of that nature. You choose a different option, and we document what is the memory limit that you actually get according to that. One thing you'll find interesting here is that if you look at a managed instance and you're used to looking at like the error log to see how much memory you get, it won't quite line up with what you normally see because we use Windows job objects to restrict the kind of memory you're used to using. And don't forget that this is still a SQL server. So improving application latency by optimizing chatty applications, tuning indexes, batching, procedures, all that stuff is the same as Azure SQL. Your skills in doing performance tuning in SQL Server today absolutely apply to Azure SQL. You just have to learn how to deploy things a little bit different, how to use the system correctly, and then how to go use all the tools you're used to doing the right tuning of SQL queries as you're used to seeing. So let's stop for a second and look at a small demonstration. We got about 11 minutes here left. We'll see if we can squeeze this down into 11 minutes. So I've got an Azure virtual machine, and I'm going to kick off this workload. This Azure virtual machine is going against a database in the cloud. And I'm going to use here DMVs that you're used to seeing to look at the behavior of this. Whoops. Let's see, here we go. And you're going to see here, I've got a lot of runnable queries with SOS scheduler yield weights in this environment. I also can use this new DMV that I mentioned before to go look and see what is the resource usage of this workload. You can see here, notice it's almost like 100%. This particular DMV polls every 15 seconds. It polls the environment to see what does the usage look like for IO, for memory, for CPU. And you can tell by running this particular DMV is going to give you information about what is that overall resource usage. And I can just show you the query I'm running here. Let's see. Come over here. We'll open it up. What is the query I'm running? You can see here, it's just this top command that's running. Notice I'm assigning this to a variable to put all the CPU usage into the server versus doing any results passed back to the client, just to show you the behavior. Now, if I'll go over and take a look at this, I can see this is almost done. It's just almost going to take like 1.5 minutes to run this. When this is finished, we can go and look at the query store to see the behavior of this query and see what might be the problem. You might can guess by looking at this DMV here that one issue we're seeing here because of all these scheduler yield weights is the fact that maybe we don't have enough CPUs. And we can even go over here and we can see with this set of SQL Server commands, what does our deployment look like? And we can see we only have 2 CPUs for this workload. So you can notice here it finished in 1 minute and 26 seconds. So if I go over to Query Store here, this is just like you do with a SQL Server. You can go find your top resource performing query. It's this query I'm running. You can see here in this case that it's averaging about 4 milliseconds, but this is running all the time. So 4 milliseconds may not be fast enough. I can look at query weight statistics. I can click on CPU. I can find out my query is actually waiting on CPU the majority of its duration. So I don't have enough CPU resources. So one way I can fix this problem, let's do this. And I'm going to do something here. I'm going to flush the query store so you can actually ensure that we see the results correctly in the query store. I'm going to use a tsql command to give me more CPUs. Yes, that's true. You can use this new tsql extension to say, you know what, I need 8 CPUs. Now notice it came back immediately. That's because this is an asynchronous operation where behind the scenes, we're giving you more CPUs. And it could be, depending on where you're deployed, that this could be just a very, very fast operation. And the only downtime you're going to experience is when we need to switch over to a new SQL server that deploys this database. For a business critical database, which we're using availability groups, we just need to fail over to another replica. So this could be extremely fast to do this. So this is going to take, in some cases, this can take even less than 1 minute to run this. And if you run this command here, you can see when this is finished, it's going to show you, do I have 8 CPUs or not? So we'll give this a second. If I go and look at the Azure portal for this, you can see here that it's showing that it's doing an update of what it's called the pricing tier. Notice it's already finished at this point. So I'll go back here, I'll run this command again, and I'll see that I now have 8 CPUs. Well, that's pretty cool. Is my workload going to be any faster? Well, let's find out. So I'm using the popular OStress tool. I'll run it again. Remember, it was like 1 minute and 26 seconds to run this. If I go back and look at my DMVs, what does it look like? Well, you can see you still have some runnable and some SOS scheduler yield weights, but there are more running weights now, and instead of just being runnable weights. And I expect this to be a lot faster. So if I go back now and look at my workload, indeed, this is going to finish in about 30 seconds now, as opposed to about 20 seconds. If I go look at the DMV I showed you that shows you the resource usage, what does it look like? You're going to see here a lot less resource usage than we saw before. Still some resource usage, but a lot less. So I'll go back now and I'll see it took 37 seconds instead of 1.5 minutes to run it. If I go back over to my reports for Query Store, I can see now that I have 2 query IDs, and notice it's the same query, but for this one, you can see that the average execution is now something like 1 millisecond. And in fact, if you go look at the weight statistics, you'll see as well that that average is much lower. So a quick example of you easily scaling your workload by just changing a tsql command to give you more CPUs. Now, if you would use serverless in this case, we would have auto-scaled that workload up to the maximum CPUs that you would have chosen. Okay, So let's finish off and talk a little bit here. We got about 6 minutes left. Let's just talk briefly here about intelligent performance to make sure you know what is capable in the cloud that is really interesting for Azure SQL. And that is, first of all, intelligent query processing, which is built into the query processor itself. This is the QP where you move to a latest compatibility level and you get faster performance with no app changes. I've demonstrated this a lot in SQL 19, and that exists in Azure SQL. Automatic plan correction, we demoed that in SQL 17. That's the ability for us to go and revert back to a good plan when you had like a query plan regression problem. That exists in Azure SQL as well. Automatic tuning is probably the more interesting one. Sorry about that. Automatic tuning looks something like this. And that is that behind the scenes, we will use Query Store to give you index recommendations. And it's really interesting because we don't just go after one query. We look at something over time here. So we use machine learning algorithms. This is part of your Azure SQL database subscription. By default, we can recommend indexes to you, or you can turn on automation and we'll automatically build those indexes. And if we detect over time that we think those indexes are no longer needed, we can automatically drop those indexes as well. This is an example of something you're going to get in the cloud that you would not get in SQL Server. Okay, we're about done today. I know that was very quick. You probably have a few questions here. This is kind of a summary of what we talked about today. It's just SQL Server. Remember, slightly different configuration, but a lot of the functionality available today in SQL is there in Azure SQL. And here's some great resources. The Azure SQL Fundamentals resource, go look at that one. That's a free Microsoft Learn workshop that Ann and I built. And then there's a performance section where you can go do the same demo I just showed you. Or go to Azure SQL for Beginners and watch some 60 YouTube videos Ann and I put together that cover all sorts of topics about Azure SQL itself. Hey, thanks for your time today. Crazy fast, I know. We only had 30 minutes. I don't know, Ben, if that was brain frying or not, but it was quick, that's for sure. So I'm happy to take the last few minutes to take your questions.
So my brain is easily fried, so let's start with that. But
okay. Okay, so well, maybe I've done my job then.
Exactly. So we got a couple of questions here. So Chris Taylor is asking, what permissions are required to alter the CPU pricing tier via T-SQL?
Great question. So in SQL Server itself, if you're a database administrator and you have access to the logical server, you have access to do that in the alter database command. So alter database permissions for the Azure SQL database are enough to do it in T-SQL. In the Azure portal, there's a concept called rollback access control, where your Azure account has to have permissions to do that through the portal itself. So you can either do it to T-SQL, give permissions that way, or give a specific Azure subscription user access through rollback access control.
Cool. Then we get a slightly off-topic question from Björn, and I know where that question is coming from. Okay. It's on Azure Arc Data Service. I don't know if you know that out from the top of your head. So basically, the question is, if you deploy an Arc instance, you're basically deploying a managed instance on Kubernetes. So will this managed instance on Kubernetes have a subset of the features, basically the merged features of SQL and Linux and a managed instance? Because while they mostly have feature parity, there's a couple of small things here and there that work in one or the other, but not both.
Yeah, great question. We call it Azure Arc Managed Instance for a reason. What you see today in the public preview is not the full set of what we intend to do. So we have a vision. And the vision is that we want the Azure Arc Managed Instance to behave and feel like a managed instance like you see here that I've shown you today. That includes all these kind of capabilities, right? However, it's built on Kubernetes, so we might implement things slightly different for scaling or availability or whatever it may be because we're using Kubernetes, whereas in the cloud, in Azure the public cloud, a managed instance is deployed by Microsoft using Service Fabric. So the answer to your question is that we very much want the vision of a managed instance to feel like a managed instance you see in Azure SQL today. We've just begun that journey.
Cool.
Great.
So Mila's got another question. He's curious, your query, it's got a new query ID in Query Store after you upgrade to 8 CPU cores. Why is that?
Very smart to ask that question. Boy, I'm impressed somebody caught that. As it turns out, you get a new query ID because a configuration setting from the client may be different. And with a general purpose 2-core deployment, max stop is constricted to 1. So it turns out that when you run a query against a SQL server and max stop is configured to 1, you get a slightly different connection option that the client sets. So we went to 8 CPUs, max stop is now greater than 1. And so we have this option called, can you be a parallel query? And that got set for the second query, which is why you see 2 query IDs. Normally you would not see 2 query IDs, but you did in that case.
Cool. Okay, and a rather broad question from my friend Rob Sewell. What are the limitations to logging to log analytics?
What are the limitations of logging to log analytics?
Yes.
Okay, so I'm not sure if you mean by size, Rob, or whatever, but there are some size restrictions, but it's pretty broad. So log analytics is actually an interesting topic, and I don't know off the top of my head what those actual size restrictions are, but usually it's pretty much however much you want to pay for, we'll store. So.
Well, if I may add to that, Rob, when I was uploading my demo logs from my Arc instance to log analytics, that worked just fine. So it seems pretty capable of handling 2 queries. I
mean, I've used it as well with Custo queries, and it's very performant. So if that helps as well.
That's true. So surprisingly so, if I may say so. Okay. I do not see. So Rob is adding on for getting the query info and connection info. I'm doing it right now, and the SQL Analytics solution.
I'm not sure. You're talking about the current solution we have where we use our own like SQL Analytics for performance, like query insights, intelligent insights. Is that what Rob's talking about?
If I may unmute myself.
Yes, please. I was going to suggest you unmute yourself because that might be easier.
So really what I'm doing is I've literally yesterday added the SQL Analytics solution to read the log analytics that we've set up for all of the options for logging SQL into log analytics.
Yeah.
What are we missing there that we should maybe gather with extended events or something else? Was really
SQL Analytics, Rob, is as you know, still in preview. And we're still iterating on that. So if you want to kind of dive a little bit further in that, you probably should shoot me an email, bob@microsoft.com, and we can put you in touch with the team to chat more about that.
Thank you.